Hello, welcome everyone. Sorry about the rain, and I guess it's just us now. So yeah, I don't know if anyone is so dedicated to come and see us. Uh, but it's good. Well, my colleague is here, so we have somewhat an audience. Um, so we're starting a little bit late, 10 minutes late, so we will end the program also 10 minutes late. Originally scheduled to end at 10:45, so we will end at 10:55. So I will hand it to the chair, Selma. Yeah.
Thank you. Wonderful to see you all here this morning. And today I'm going to be joined by Masahiro Shiomi and by Andrew Wilson for today's session. And we're going to basically do 20-minute presentations by each of us, and then you'll get 10 minutes to ask questions to that specific person. And so I'll start first, and I'll introduce you two as you come up slowly. So I'll go first, and I'll introduce myself. So I'm Selma Sabanovic. I'm a faculty member at Indiana University Bloomington in the Informatics Department and Cognitive Science program. And I'm actually really excited to talk about this today because I've never talked about this project like all together before. It's something we started 3 years ago and is just kind of towards the end of its initial funding stage. So I'm really looking forward to any feedback or questions or thoughts you have on it. Just to give you a little bit of kind of insight into where I'm coming from. So I'm trained as a social scientist. I have a PhD in science and technology studies. And now I work as a human-robot interaction researcher. And I focus on social robotics, so some questions about how to design sociality and social interactions with robots, and then also assistive robotics, looking at different populations. We've done older adults, worked with older adults for many, many years, more than a decade, and then we've also done some work with children. And so I went from kind of myself doing field work, this is me as a PhD student, to having a kind of lab that's gone through several iterations where I work with different students, people from different disciplines on projects together. And so along with kind of talking a little bit about me, I just wanted to kind of introduce this term of Ikigai, which I'm sure is familiar to some of you, but I want to tell you kind of where it came into this project from. So the first time I actually heard of Ikigai was from my mother, who was reading this book. She's in her 70s. And I didn't actually pay much attention to it, even though she was really excited to read this book and she thought very positively of it. But the second time I heard about Ikigai was actually when we started talking to colleagues at Toyota Research Institute. And we were trying to come up with a project for this funding vehicle that they have called University 2.0. It's a way for a researcher at Toyota Research Institute to work together with an academic team in a university on some project of interest to them, but tied to Toyota Research core mission. And at that point, they clarified, we were talking, we wanted to do something with older adults. We wanted to do something that would bring older adults kind of more in touch with their community and with each other. So things dealing with social participation. And they told me about Ikigai as a kind of aim of robotics development in Toyota Research Institute. And so we kind of translated our understanding of wanting to kind of get more engagement and social participation into the lives of older adults into looking at how we might design robots to support and maintain Ikigai. After that, we did a bunch of reading. We came across some of the early mentions of Ikigai in the 60s in this book. And then later on, one of my students, Waki Kamino, was in Japan over the summer, and she kind of studied what was going on with Ikigai in Japan, and found out that it's one part of kind of government policy to engage older adults more with their Ikigai and support it. And there are many municipal organizations, even kind of older adult colleges, where you can go and kind of get involved in activities or learn how to better support and maintain your Ikigai. So our project is kind of contextualized in this cross-cultural and cross-time understanding of Ikigai in some sense. And so what we're trying to do in the project was to figure out how we might be able to use social robots to help older adults maintain and kind of think about, become more aware of their sense of meaning and purpose of, in life, which is what Ikigai stands for. And we were kind of interested in two aspects of it, which I realized I didn't explain, but was on this slide. One is kind of the source. So, you know, what do they think are the sources of their Ikigai? And the other one is the feeling. So when and how do they experience this feeling of Ikigai? One thing that I want to get across in this presentation, I think the thing we kind of realize the most is how complex the notion of Ikigai is and somewhat abstract and confusing. But what we also found is that research in robotics can in some sense be a source of Ikigai and inspire a feeling of Ikigai from both the researchers and participants. So I kind of want to talk about these two aspects. So recently we were thinking about what we've done in the project, and this was kind of a surprising thing for us. But over the past 3 years, we've worked in different ways with kind of over 1,000 participants in 2 countries. So we did the study in US and Japan. And we did a lot of different methods: surveys, interviews, co-design, user studies. Now we're going to do a in-home evaluation. So we tried to kind of understand Ikigai and where robots might fit in relation to it in a lot of different ways. So I'm just going to walk you through quickly some of the things that we did. So we started, as social scientists maybe often do, with just trying to understand, what does Ikigai mean to people? And, you know, how could we maybe connect robots to it? So we initially interviewed experts. Some of them were academic researchers. Some of them were older adults who actually actively work in this kind of attempt to engage other older adults in awareness and maintenance of their Ikigai. And so some of the things we did some interviews, we did some co-design workshops. And some of the things we talked about was top-down, so kind of from the government, types of activities, as well as bottom-up approaches in these different, for example, Ikigai community centers that they have in Japan, of how they were kind of trying to work with older adults. We also showed them the robot we had picked. We picked a particular platform that we thought we could work with, the QT. You're going to see it soon. And they were kind of generally, you know, potentially interested in it. They like the idea that it could be used for different activities. They like the notion that maybe it could show empathy towards users. That was important to them. But there were some concerns from the beginning, such as privacy was a big one. We also did a lot of surveys and interviews with older adults, both in the US and Japan. And we kind of, something that we found that was interesting, we found that there were kind of different people who lived by themselves and then people who lived with others, whether at home or in nursing homes, seem to have different, report different sources of Ikigai, not necessarily the feelings, but the sources. People who lived alone were focused more on their own hobbies, learning, and a feeling of independence. People who lived with others talked a lot about relationships, particularly with family, and then kind of giving back to the community type of things. And they all seemed also to be potentially comfortable with talking to a robot, but some were concerned about maybe talking about negative events or memories and what would happen there. And as we were doing these kind of surveys and interviews and more general questioning, we also started working together with the local memory care facility. This is a place where older adults with dementia go sometimes for the day, but they're also live in residence. And they actually have a daycare. Somebody yesterday was talking about a place that has older adults and kids. This place also has a daycare for 3 to 5-year-olds, where the older adults and kids get together. But here we kind of did two things. We worked with the director of the facility to kind of help design some of the studies, the functions of the robot. And also we did co-design with the dementia care, with the people living with dementia, to see how the robot might fit into their lives. And I'm just gonna show you a quick little video of some of the things. I don't know if it's too loud, but I don't know how to make it less loud. And this was particularly inspired by talking to the director, who kind of showed us this framework that they had about kind of constantly supporting the well-being of older adults. And we started designing these co-design activities with this in mind. There's a whole paper about this if you're curious. And from these activities, and then also some of our observations in the elder care facility, we kind of tried to pick some activities that the older adults we thought could do with the robot that might relate to their Ikigai and also be something that's kind of generally related to their well-being. So the first activity we did was kind of a photograph-based activity. It's based on something called a time slip, which is usually you show somebody a photo and then you kind of go through this creative process of talking to them about what they think is in the photo, what's happening. And it's a kind of, we thought, one, this is an activity that's just beneficial in itself, but also it might allow us to collect some data about things that the older adults find meaningful that we could then maybe use for kind of the robot to provide recommendations or talk to the person some more. So I think if I press this, you're going to see this is kind of some of the observations we had of this kind of activity in the place. This is the robot.
I am glad you are here. Welcome to today's story-making activity. Let us make up a story about this picture.
You can just make up something?
Well, I think right now he's playing in the water in the lake
So they were looking at the picture of the kid.
where he lives.
And of course, we used Wizard of Oz first.
Tell me more about it.
I can remember being at Yellowwood State Forest in Brown County, Indiana, on a lovely afternoon a couple of years ago.
I think it turned out to be wonderful.
Oh, I do too.
Have a happy rest of the day.
Well, thank you.
Bye.
Bye.
So here we followed kind of the typical way that activity ran with a person, with the idea that these activities were only done maybe once a week in the daycare, and we thought maybe the robot could come in and do it more often if people wanted to have these conversations. But one of the things we also noticed while we were just initially testing the robot was that people would be much more animated if they weren't looking at a random photo, but if it was a photo that they took or something from their lives. This actually was kind of random. Once when we were sitting with a participant evaluating the robot, somebody came in and gave them their mail. And in the mail was a card, and in the card was a photo of their previous colleague, and they just had such a great time then telling us about the colleague, how they used to work, how much they loved to work, all the things they loved about their work, that kind of thing, that we then basically switched the activity into using their own personal photograph. And we also realized we needed to kind of do more co-design in some sense to figure out how this robot should interact with people. So for the past more than a year, more than 12 months, we've been doing co-design in our lab with kind of a panel of older adults that come in every few weeks, and we talk about different aspects of the robot, how it should talk, what nonverbal sounds it should give, data collection, privacy concerns, that kind of stuff. And here's, I think, a little video of that.
Programming and healthcare management. My name is Steve Taylor, and my interest in my introduction to this was because I have dementia and Alzheimer's.
And these people don't all have dementia. It's a combination of caregivers, people with dementia, and just older adults.
At IU, and I took an early retirement.
So I think what's very valuable here is we actually have a team of,
That's kind of a way of talking.
yeah,
with
embarrassingly myself.
Another to talk to your.
I'm Kate Suey. I am employed at Research Institutes, and I have been.
But then compared to
And
these
so we
other
do
states
different
here
kinds
on
of
the
activities with our researchers.
Coach eats and eats out. Wow.
Show that one.
And of course, one of the first
What's the
things we talked
circus?
about was
That would only
Ikigai.
be
How do
one
you think
response.
about it?
Okay, what will be some others do you think that would
Well,
be helpful to somebody in that situation?
The questions of what did you expect or what do you expect? Either way, would.
Did I hear that right?
So here they're designing facial expressions for the robot.
Can you describe, I'll pretend I was at the World Series, I hit the ball and be,
Yeah.
so
And then they also get to test out the robot as it develops. So it's kind of every time they test a new capability.
This is my nephew and his wife and their 2 children. They are very important to us because they represent part of who we are and who I have become.
And so over time with the co-design panel, we kind of developed and improved the photo activity. And so, and we also incorporated GPT into it, which I'll say something about in a second. I'm going to skip this other, it's just another more involved conversation. But another activity that we wanted to do, because one of the things in the early surveys we noticed was that people sometimes would report kind of different sources of meaning, but like not necessarily be aware of whether they're feeling Ikigai or not feeling. I mean, Ikigai in general, even for Japanese people, is kind of an abstract concept. They're not running around thinking about, oh, my Ikigai all the time. So we thought maybe another thing to do is kind of provide some reflection activities. So here's some video of those. These are in the US, but we did them in both US and Japan.
Let's talk about accomplishments. What is something that you have achieved in your life that you are proud of?
Oh, well, I worked 50 years as an electrical engineer, and I'm pretty proud of some of the jobs that I worked on.
Tell me about something you've been doing recently that made you happy.
I have been communicating with my friends more, and also just communicate more with family.
Have you spoken to anyone in the past week that seemed particularly meaningful?
I helped with the Hanukkah bazaar, and I go to temple and have a good time there. But at temple I know more people because I've been there for 50 years.
Do you have any plans for today and tomorrow?
Planning for church, I plan for Sunday. So next Sunday, I plan to go to church. I will go with my friend in her car.
What is the one small thing you can do tomorrow to make progress towards these monthly goals?
Well, just being available, be supportive of them, and understand that the challenges that they're dealing with.
How do you think you are going to celebrate after achieving this goal and the steps you are taking towards it?
Hopefully I'll have some smiles.
So the idea here, and this was kind of particularly interesting in some cases for the older adults with dementia, was to have something where you could kind of tell it your goals and then it could later help you remember them or see what you've done towards them to kind of be aware. And we did some evaluations of this just kind of in single shot interactions. And here's some of the responses. So people thought, it could help them kind of think about themselves, and be more aware of what they're doing. They said it made them think about things they had never really considered before so much consciously, and think about themselves and maybe if they're stuck in a routine or they want to do something different. And interestingly, one of the things that came out in some recent tests we did in Japan was that people said that they really felt listened to by the robot. This is, I would say, partly because of GPT and its ability to respond in a very kind of contextual manner. But one of the things that kind of stuck in my mind is one participant was saying in particular that people often don't listen to you. You talk, but they don't listen. And the robot actually seems like it's listening because it could, and this came from the robot just kind of summarizing what their conversation had been. So, you know, kind of an interesting insight. As I mentioned, we integrated GPT. It was kind of a godsend in some sense because we were developing things initially in English and we were going to have to make everything in Japanese, including the dialogue system. And suddenly we had a Japanese dialogue system with the press of about or like one prompt, speak Japanese. However, that's not really a solution because one of the things that came out is not just the language, but actually the way you ask questions. It could be very cultural. And so some of our tests, one of the things we want to think about more is in terms of like mannerisms, nonverbals, or when you ask a certain question, you can't lead in, you know, with a very personal question if the person doesn't feel close to the robot. In some sense, it's almost easier to do it in the US than in Japan. So thinking about some of these kind of more culturally appropriate ways of actually the conversation flow. We also in the initial plan had this grand scheme of coming up with some kind of Ikigai model, which in some sense, you know, was kind of a technical side of it. And I have to say, didn't get very far. And maybe someday we can get a little further. I'm not sure, but I just wanted to kind of come out with it. One thing that we did do, however, was actually collect kind of a data set of people talking about their Ikigai, both to humans and to a robot. And one of the things we want to study, this is with 80 people per country. And so one of the things we want to kind of look at is, do people talk differently to a robot than they do to a human? Or do people kind of talk about their Ikigai differently in different ways? Or can we even tell when they're talking about something they really care about or not? So just some quick research takeaways. I mean, I think we found that I was actually kind of astounded by how deep the conversations people had with the robot are. And so I think one of our questions here is, what do you do with that now that we've kind of prompted that response? I think what we were really excited about is that we were able to kind of work together with adults with very diverse cognitive capabilities in kind of integrating all of us together into the design of the robot. There's a lot more nuance, a lot more work to do. I feel like this is just like a baby step in some sense. And it took a lot of people. One thing, there's a little video here. We kind of really bonded in the panel with the robot.
Don't think I understand that one.
So now we all have this like move. The robot does this. And now everybody on the panel, every now and then we all go like, and it's our little celebration or whatever robot gesture. And I think what I mentioned at the beginning, like one of the things that came out of the project is that different people kind of found their own Ikigai in it in different ways. So if you remember the co-design panel video, there was kind of an older adult who seemed to be guiding the conversation. He was actually, he used to be the director of the Center for Aging at IU, or university, and he worked with us on all the co-design panels. He's a community researcher now. Here he mentions, you know, he's towards the end of his career, but this allowed him to bring together a bunch of his interests. Our students, I think in this project, also for me, it was one of the most collaborative projects that I've really ever been on, and I've been on several, so this was kind of cool for them in that way. And I think what we were really excited about is that it seemed to really benefit the participants to be in the studies. They all talked about how meaningful it was to not just get together, which we've seen in other kind of co-design activities. It's a social activity. It's fun. You get to be with other people, but also that they felt like they were kind of contributing back to society and to science and to something meaningful was interesting to them. So what do we do from here? I think I still think promoting and maintaining Ikigai using robots is you know, something we could possibly work on. We have some activities, but I think we really need to think through, some folks mentioned yesterday, is how this fits into the broader context of care. This robot is relatively easy to use, but if you've seen, we're usually there when it's being used. We're going to do some studies in a few weeks where we're not going to be there. So we'll see what happens. It's exciting. I think thinking about how to make participation in research meaningful to participants is another important component. So particularly starting with the co-design for older adults with dementia, we really tried to think like, not just how do we kind of get information out of these people, but how does this working together mean something to them, and give something to them. And then I think in our project ourselves, we kind of from the beginning had this trying to manage kind of the social push and the technological pull. Ikigai is complex, robots are complex, you know, you need to do certain things to get funding. Other things might be more relevant to actually kind of the communities that you're working with. And so how to kind of keep these parts developing together, and kind of keep the older adult centered is a constant struggle in some sense. So, you know, something to keep thinking about. We also got to take the robot all over the world. And I just want to thank my awesome team of many, many researchers. And I'm happy to answer questions.
Thank you, Selma, and for the talk. And so you did a comparative like a study in between two countries. So I wonder, like, you know, like for the Americans, right? And so, is there a way to measuring like their acceptance of Ikigai? And because this might be something new. I mean, this is totally new to me, right? And so I like it. And so I don't know, like out of the 500 participants, and is there a way and you can assess their interest or, you know, before you started the study?
Yeah, so actually Japanese researchers have created Ikigai measurement. So this was like a big topic in the 60s, and then it kind of apparently died down, and then it came back in the 2000s, both in kind of popular culture, in the government policies, and again in research. So there are two kind of validated questionnaires, if you want to look at it that way, for Ikigai in Japan. And they've also been done, kind of tested in different other countries in Europe. And we basically tested two of them, plus kind of some US scales that have to do with similar issues, kind of happiness, life satisfaction, social participation satisfaction. And so, you know, the questions that are praised are not like, how's your Ikigai doing today? But it's kind of an itemized scale that's asking about things like, you know, I can't remember the questions right now, but it could be things like, you know, how much do you feel like you have a sense of meaning? Or, you know, when you wake up in the morning, do you feel like you're ready to go with the day or whatever? I just invented those. So those are probably not on the scale because I can't remember them. But yeah, so we were part of what we were trying to do is see like, okay, these scales were developed in Japan. Like, does this cross over? Does it match some other concepts that are also used in kind of Western social psychology? Yeah. But I mean, in terms of just Ikigai, I feel like even asking Japanese people, you know, how do you feel about your Ikigai is not a very sensible question. Like, people don't know how to answer that. Yeah. So figuring out other ways to ask has been the motto. Yeah.
Hi, thank you so much for your talk. So I'm not a robotics researcher or anything like that, so please take my question with skepticism. But I was just thinking about like this human-robot interaction and what kind of activities it might kind of parallel. For example, I thought of therapy, I thought of video games, and then there's this idea of like maybe like a longer-term relationship. And I was wondering, you know, as you think about like how robots can foster Ikigai, do you have in mind these different kinds of relationships? And, you know, it seemed like watching the videos, it seemed kind of like a game. And I could also see that it could be a kind of therapy. But then, you know, how does one go deeper or something? And how do you And is that healthy, or is that even a goal to go deeper? I mean, I think about like somewhat dystopic films like Her, where you kind of fall in love with a robot, and so I'm just wondering like how you think about this human robot relationship, and do any of these existing models fit that or not?
Yeah, so I mean, those all are definitely kind of almost applicable. I tend to think of it so for these 3 years, I know it sounds like a long time, but in some sense it's not. We've been really kind of trying to focus to make the robot something that you can kind of talk to, like, so figure out what the activities are, work on the kind of conversation flow and naturalness and those kinds of things. But I actually don't think that just designing the robot is sufficient. So it has to really fit into a particular set of other human relationships, and either so it could be used in the home, it could be used in a care setting, and depending on whether it's used in one or the other, it actually inherently needs to engage other people. So there are other caregivers there. I never think of the robot as something that's going to be the main center of interaction for the person. I'm actually kind of more interested in seeing how it can connect the person to other relationships in their life. So whether it's with the caregiver, whether it's people in their community, whether it's so we haven't gone there, but one of the ideas is one of the things people wanted is things like, the robot could recommend what's going on in the nursing home. Like, oh, you seem to love art. Look, there's like an art activity tomorrow. And your friend Dolores from 2 doors down also likes art. Maybe you two could go together, something like that. So I see it more as something that's really maybe a bit of a fulcrum in a larger social setting, but certainly not the aim in and of itself. And the aim would never be to have the person interacting with this thing more than like 5 to 10 minutes at a time at most, right? And so, but in terms of the interaction, I stay away from the notion of therapy because I feel like that is too deep of a role for this kind of technology. I mean, it could be maybe part of therapy where there's a person there that's actually guiding the thing, but I don't think any kind of robot will ever be, responsible or sufficient to do that work. I almost think of it as like a kind of like a reflection tool. It's like a kind of a part of you on the outside in some sense, which is just kind of probing you. And it's more that you're thinking and reflecting yourself. It's just kind of a tool for probing you to think about stuff, almost like, but a more interactive one. So early on when we started doing this Ikigai stuff, you can buy this thing called like an Ikigai diary or whatever. And every day you do an activity and it's like, today, what did you do that was meaningful? Go outside, smell the flowers. How do you feel? It's just different things asking you to be more aware of yourself and your surroundings. And so in some sense, this is kind of like an interactive way of doing that, rather than like taking a paper and pen, and maybe like I started the Ikigai diary and I did one and that was it. And that was like 3 years ago. But maybe I'm just bad at diaries. Okay, I think last one.
Yeah, thanks. A really fascinating project. I guess my question follows up the previous one, which is, I mean, it does. I get your point that it's it shouldn't be centered and it's not necessarily doing therapy. Actually, the parallel that comes to mind is a kind of turbocharged version of Eliza in terms of this kind of rephrasing responses, active performing active listening to what people are entering. But I mean, it does seem like it could well elicit quite therapy-like responses. It could elicit difficult conversations like, have you done something meaningful recently? No, and I'm don't feel good about that. I mean, how do you deal with those kind of potentially quite problematic responses that might require further support, and possibly kind of therapy-like support? Thanks.
Yeah, so we have come across those responses. We haven't so far, I mean, we've never used it without other people around. So in some sense, almost if there seems to be a need for further care, the other people who are around, whether it's the caregiver or sometimes it's us, kind of help manage that afterwards. I actually don't think that the robot itself will ever be able to manage those conversations. So I think it's more about figuring out what is then the appropriate way for a caregiver or somebody who's a human to kind of be around or be in a kind of callable state or something like that, where you can actually have them help manage that. I really don't hope. I mean, the robot actually gives relatively, with the right prompting, it gives actually relatively kind of helpful, empathetic feedback that's, okay in the moment. And all of these interactions so far have been one or two shots. So they haven't been interacting with it for, many times over a longer period of time. We're actually going to try that in the next few weeks and see what happens. So people are going to use it for a couple of weeks. But I think that's kind of our next side of the questions is when you put this into this situation, how do you actually manage those issues? But yeah, it's definitely there. Thank you. So I think our next speaker is going to be Masahiro Shiomi, and they're going to set up. So Dr. Shiomi is a senior research scientist and group leader of the Agent Interaction Design Lab at the Interaction Science Laboratories at ATR in Kyoto, Japan. He's also a visiting professor at Kobe University and does research on human-robot interaction, social touch interaction, robotics for childcare, and multiple social robots. So.
Thank you for introduction. So, and thank you for Angelina Sensei to invite me as a speaker, and thank you for the team of the Angelina Sensei, so kind of support for that. Okay, so I'm Masahiro Shiomi from ATR Japan. So my title is the Cloud Network Robotics that interact with people in real environment. So as yesterday Sumioka-san introduced, ATR have been developing a various kind of robot system and evaluating their effectiveness in both laboratories and real environments such as shopping mall, nursing home, and so on. So as shown in the figure, so we use this small desktop size human robot for the child care kind of a storytelling, conversation service, and this one is Android, Erika, a human robot, quite a human-like appearance robot for the touch interaction, or the TDVR-like robot, or the animation character robot, which we collaborate with the company. So if you are anime freak, maybe you know the touch comma is the Ghost in the Shell. So we developed this kind of robot for the shopping support, and Hiro-chan, as yesterday Sumioka-san introduced. So for this kind of, to provide this kind of system, so we developed a cloud network robot system to connect multiple, we say cybernetic avatar, but it consists of the social robot, virtual CG character, virtual agent, mobile robot, so various kind of systems, and collaborating with the operator, multiple operators. So because semi-autonomous systems are really important to realize a safe and trustworthy service in this current situation in the real environment, such as stock rock, customer service, guidance, and reception. And involving operator has another good things to to enable people can work remotely, even though they are retired. So recently we conducted a field experiment in the real society by using the cybernetic avatar, including social robot, to verify active social participation for everyone. For example, in ATR, we conducted a reception and guiding service at the entrance as a company buying the Erika Android robot or the mobile robot. And another collaborator doing some product recommendation service in the souvenir shop at the Kobe Airport in Japan. Or another researcher doing education support for children with developmental disability, collaborating the retired elderly people. So in this talk, within this trial, I would like to explain the two examples focus on the physical support. Might a little bit of the work was, but I believe this is would be fit in this symposium context. One is the shopping support for elderly people. Another one is the social touch interaction for the disability cares. Okay, the first one, the shopping support. So many Japanese government report or document say that, as you know, the Japan is in a super aging society. So it's really important to realize social robot that support senior citizen, elderly people. And many of the research focus on direct care for the dementia people, elderly people in the nursing home or the care staff. But in this study, we focus on relatively healthy elderly people for their daily activity as shopping, because shopping is a good daily activity for them to do some exercise and making an opportunity to collaborate or interact with other people in local community. And these activities are important for prevention for the SICs. So and prevention is better than care. So then we focus on this kind of activity support. So here, what kind of presence should robot have in assisting them in their daily lives in this kind of context? So in other words, our research question in this presentation is the robot a tool or the partner? Of course, many of the robot service regard as a robot as a tool because simply the best, and so robot bring the impression of a reliable service provider. But we believe the partner perspective, as before Selma says, robot listening to during the conversation, the listened by robot is really important for the conversation. As similar to this context, the partner concept is really important to provide a positive impression, which will be contribute to increase the activity, the daily activity, even though such kind of concept is not needed for providing services, particularly for shopping support. So here we investigate the effect of the partner perspective in the context of supporting elderly people in the shopping context. So this is a map of the supermarket shopping mall where we collaborated the experiment. In the entrance, we use a RoboBee, 1 meter, 20 centimeter human robot, mobile robot for this service. So in the entrance, the participant will use the robot, and the participant gives a basket to the robot arm, and then robot following the participant during the shopping. So you can see the participant checking the item, and the robot is following by taking the basket. So they don't need move their item in their own. So robot can bring that. Then doing shopping, but of course the robot cannot pay the fees. So then participant receives the basket from robot before the payment process, and in the entrance again, so they are for greetings. So this is a scenario of the experiment, and this is a condition of the experiment design of the this study. So we prepared 2x2 condition, in total 4 conditions. One factor is a conversation. So actually we prepared a basic speech command for the robot, such as stop, follow me, or for example, such these are needed function for the shopping support. But we also additionally prepare simple chat function depending on the place. For example, the place for the meat or fish or something. And we prepared nothing, so just walking around condition. So another type is another factor is the cat and human robot. This is purely the focusing on the appearance effect of the robot. So this experiment is within participant design. The 24 elderly people joined that. So we paid the money for the shopping, and they joined the shopping during the specific 4-day period. So 4 times they are doing shopping with our robot. And also robot are semi-autonomously controlled, are part of the wizard of approach. So I will show some video. Voice is Japanese, but in English text here. So in the entrance, so RoboBee introduces itself and say, I'm looking forward to shopping with you. And to ask to get the basket. So maybe first participants are a bit scary or confusing, but once she understands the role of the robot, so she enjoying the shopping like that. So it's usual supermarket. He or she can freely doing the shopping like this. And this is a small chat function. The robot say some information. Of course, robot cannot eat meat, but the participant say something depending on the robot chat. So this is a simple chat function effect. And then this is the end of the shopping. Appreciate this experience, and participant also thanks to the robot. Then the participant take the items and say again and say bye bye. So this is the typical scenario. So we gather the two types of the result about the questionnaires and the interview. So this is the question result. So we gather the three scales related to the social acceptance model. So passive enjoyment, passive ease of use, and the intention to use. As shown in the figure, left bottom ease of use are not different between any conditions, but passive enjoyment and the intention to use are significantly different in the type factor and the compositional factor. This result means that participants significantly prefer the conversational humanoid robot. So then we conducted a semi-structured interview for gather why they preferred. So this is the conversation factor interview result. We coded the interview result and write down, then coded that. So into the four category. So then one participant said, with conversation, they perceive that they are with or doing things with someone. So feeling some kind of existence of the robot together with someone. So another category is certain participants say with it utterance or communicating with it, they perceived positive feelings. So the enjoyment, such as enjoyment, better feelings, and lost loneliness due to the conversation with the robot. And the combination of A and B categories, there are 8 participants. So it means many of the people are positively evaluated the conversation factor. Only 2 participants are, let's say, neutral. The conversation function did not change their perception, but only 2. So this is a type factor, so appearance effect that. So first category, 16 participants say the positive effect of the human appearance. With human robot, they perceive that they are together or are doing things with someone. So this sense is maybe really important for the social robot, I think. So they perceive some kind of human likeness in it. So the second category, there are no participants, but I'd like to introduce this one. So using a cart robot was very easy because it was simple to put item in the basket. So this is the evaluation for the ease of use in the cart type robot. And C, category C is the combination of A and B. So there are 4 participants. So only one participant provided negative impression about the human robot. So using the human robot was difficult because it suggested the feeling of exploiting the robot. So only one participant say this kind of negative opinions, and 2 participants provide a neutral opinion. So robot type did not change their perception. And otherwise, just chatting due to the big, regardless of the interview, so we couldn't categorize. But generally, there are positive feelings about the conversation factor and type factor. So yeah, the conclusion of the shopping support is the result reveals that the participant significantly prefer the conversational human robot as a shopping assistant partner. So both conversation and human-like robot contribute to better acceptance and may encourage their enjoy for the shopping activities. Also, the interview data indicates the conversation would provide positive feeling. So I would like to say the important thing is the sense of together with someone for the social robot is really important. Oh, and I would like to say the gender difference, we didn't find that. So a male and female participant both showed a similar phenomenon in this study. Yeah, so the take-home message from this first study is that together with someone, sense is important for social robot design, we think. So, and next one is the social touch interaction. It's a bit different from this shopping support. So I'd like to explain abstractly the overview of this one. So maybe a few years, 5 years, until 5 years ago, many of the social touch interaction between robot and people is focusing on the touch from people to robot, like a Paro or a Pepper, for example. But we are interested in the different style. So touch from robot to people. Of course, it's important to consider the safe and trustworthy interaction with people, so let's say anshin anzen. But this kind of touch interaction is of course also important for realizing application for child care or nursing care, so as active touch interaction. And also as in the before the trial, from the partner perspective, so enabling touch interactions is essential. We think essential to realize both physical and mental support by social robot. So then we developed this kind of teddy bear type robot for doing the hug interaction. Let me see. So you can see this robot, Mofuri, hugging the people and stroking back. Maybe you can see, or even though she is wearing a mask, so she is smiling after stroking and head stroking like that. So unfortunately, this is a 2-meter size, so I cannot bring this robot to here, and I cannot present to Angelina Sensei. But if you come to the ATR, so you can try this one. So this developing robot is focusing on hug interaction. Why we focus on hug interaction is, so our before study showed that the hug interaction have a, how can I say, make a behavior changes. So this is the older version of Mofuri, and in this experiment, the robot hugging a guy and encouraging the self-disclosure. So the robot say, I want to know yourself. Then, so this person say, so his names and ages.
33歳。まあ結構おっさんやからこんなぬいぐるみ抱きしめるの恥ずかしいけど。
Embarrassing, but he's really enjoying this interaction. So we compared the 3 conditions. So one is the just a talking situation. Second condition, just a hug. Hug only means people hug the robot, but the robot didn't hug back. And the third condition is this video, reciprocated hug. And as shown in the right figures, only when the robot back the hug, the interaction time and self-disclosure ratio is increased. So and self-disclosure is really important to make a positive relationship between the human and also human robot. So then we are focusing on this kind of hug interaction. And currently, we conducted some field trial at a school where supporting individuals with ASD or ADHD. So we have been conducting more than human trials with collaborating with a counselor. So counselor talk with the such individuals by using this robot. So tele interaction by using hug or without the hug. And our results show that huggable interaction significantly relaxes in such individuals. So then, so we are using this kind of robot for the disability cares. And I have a bit of time, so I'd like to explain another activity. So currently, we are doing some for the only typical development children, but we are using this robot for English learning support. So here, so this child is again the stroking the head and listening the English questions. So just say something. Yeah, and on the display to picture here, so she chose A or B, something like that. So we found that this kind of stroking head activity during learning with the children's performance, maybe they are being calm and can focus on that. And then we conducted the other right figure. So we conducted experiment in the kindergarten. So many people gathering to be touched or hugged. And we conducted storytelling and English learning support. So in near future, of course, we can use this kind of robot for children with disability or the ASD, ADHD children in the future. And finally, I'd like to introduce another activity related to Sumioka-san. So maybe you know Hiro-chan, but this Hiro-chan can move its arm. I'm moving this a little bit, but it can touch the finger of the hold users. So we try to install this kind of Sabatte Hiro-chan. Sabatte means in English, the touch me. So touching Hiro-chan, the investigates how this kind of touch interaction change activities or passive impression of the elderly people in nursing care. So yeah, okay, so this is the conclusion. So we are conducting several field trials with social robot and introduce 2 examples focused on the particularly physical support. One is the shopping support for elderly people to support their daily activities, and another one is the social touch interaction, actually the physical interaction with people particularly for the disability cares. So thank you for your attention.
We're ready for questions.
So when I did
the research for Telenoid, another robot, we found out that like there needs to be some kind of intermediary to kind of help support the use of the robots, like Miyazaki-san, who is like the Telenoid company, who is kind of help training the care workers to use the robot, or helping the users to kind of interact. So do you see these robots that you have presented needing like some an intermediary person like that to help them kind of get used to the robot? Or does it, I guess what I'm saying is like, does it require additional kind of labor to be the intermediary? Yeah. And another question is it's about kind of the monitoring and evaluation process of these robots, and like how what's the like how do you have people participate in the evaluation and monitoring process? And yeah.
Okay, first I ask the second question. So the monitoring process or the evaluation process of that. So the for the Mofri study, so we collaborate with the medical doctor and the professional counselor, and then so they observe the interaction situation of the individuals with ASD and ADHD, and also we get asked the directly provide a questionnaire to the individual. Again, and also that we get some physiological data by using sensor. From this kind of different kind of view, so we evaluate how this kind of touch interaction is effective to the robot, to the individuals. And first question is burden for the additional burden for the control. Yeah. For the, of course, the particularly for shopping assistant, a bit also because then many operator or staff supporting that, but maybe in the current technology, let's say using a ChatGPT or the SLAM or some deep learning system, it's easy to be autonomous. So of course the cost of performance is not good yet, but to test the concept of this kind of system, so we can decrease the human load. On the other hand, for the counselor part is maybe a bit difficult because this kind of counseling interaction is, let's say, it's difficult for human too. So it's new work, I think. So, but so now we are gathering the data how people touch to the another person. Then we modeled these data to realize autonomous touching depending on the conversation context. So this kind of function increases the autonomy of the controlling system, and then the counselor or the remote worker person can focus on more important conversation topic, typically, particularly for the important things about counseling or the care, or for example. Yeah, so currently, we are developing this function now.
Hi, thanks for your research. This is fascinating. I was really curious or interested in the kind of division that sets up the experiment between tools versus partners, right? Because we know in Japan, we have kind of very interesting histories, different from other places, where tools can also be kinds of people, right? When we think of like tsukumogami and things like this, right?
Yeah.
And so I'm wondering, and your second experiment about the robot that touches people kind of points to a third, if not many other kinds of categories of human-robot relationships besides tool and partner, right? So I've heard so many people in Japan say, you know, their dream is to be hugged by Tonari no Totoro, right? And I imagine some of that imaginary might have been built into this experiment a bit.
So I wonder if you might see any value in sort of building on those stories in Japan and those traditions and thinking about, are there more categories of a kind of helper robot in the supermarket beyond the tool and beyond the partner? I'm also thinking about, GrooveX's Lavat robot that we talked a little bit about yesterday, who doesn't speak, right, but makes noise and makes connections with people in a way that, because it doesn't speak a language, it doesn't require the sort of social obligations that the humanoid robot did, the bowing and the thank you and the sort of making sure the robot is okay and following along. But it's not as impersonal as the tool scenario, right? So there's a different kinds of connections there that I wonder if they might support people in different ways beyond the category of tool and humanoid-based partner.
Yeah. Thank you for good question and difficult question. So the concept or the perspective of robot is I can say changing the distributing of the robot, because this is a little bit old. So, but in recently, as you say, so also the robot or some pet type robot has different perspective, and in particular for Japanese people like this kind of social robot and regarding as a partner. And I'm interested in the more, how can I say, how relationship between the robot and people changing time by time. For example, we installed this RoboBee to this supermarket 1 or 2 years. So then we conducted some interview for the customer. So they say RoboBee is a kind of mascot of this shop. So this also the changing the perspective of the perceived relationship. So I mean firstly, we focus on the tool or partner perspective in this study, but in reality, we try to conduct long-term installation for the real environment. So then the relationship we are changing and building more strong bonding relationship, even though without a conversational interaction. So it's not clear answer, but I'm interested in for how robot relationship changing the time. And this is really interesting research topic for the long-term interaction, particularly for human-robot interaction research. I love the long-term interaction. So we are interested in this. Thank you very much. Yeah.
That's great. Thank you.
I have maybe a quick one, which was with the robot that's petting you, and I agree with wanting a hug from Totoro. I mean, who wouldn't want a hug? But have you talked to people about how are they feeling when it's touching? Like, what do they think is going on when the robot is kind of softly patting them on the head or, hugging them?
So we conduct some questionnaire, and the trust scale is changed depending on the touch style. So just this kind of patting is a neutral condition for us. This stroking condition is a more trustable or feel the bonding that. But majority of they are saying, but some people of course have some, I can say, negative impression. So I mean this kind of touch interaction, I believe this is good interaction, but it's not silver bullet. So sometimes people hesitate that. So we have to think about what kind of the personalization of touch interaction would be important, particularly for the ASD or ADHD people have some typically how can I say, hesitating to the touch interaction. So in that sense, so basically that's good for trustable interaction, but also we need to care about how design touch interaction to people.
Thank you very much. Okay, so time for the last speaker in this session, who's Dr. Andrew Wilson. He's a computer scientist, researcher specializing in virtual reality and augmented reality. And he currently also serves as the director of research computing at Pomona College. His work has involved pioneering the integration of VR and IR technologies in research and education, demonstrating their practical applications, enhancing learning experiences and accessibility. He's also worked on using VR to replicate the experience of students with schizophrenia. Also worked on using VR in PTSD research and other ways to help it use it to mitigate the impacts of mental health issues. So let's welcome Dr. Wilson.
Thank you. Can people hear me? I've got a lapel mic. I can't use my hands when I'm talking, so it's okay. So I've got a mic. I've got a lapel. Yeah. So I can't use my hands when I'm talking. I use my hands a lot. So yeah. So I'm going to take a little bit of a different approach. So I'm Director of Research Computing here at Pomona College. I apologize for my accent. It's a very unique British accent. I also apologize for the weather. Like, we don't always mean to bring the weather with us. And also to the other British folks, I have a supply of Yorkshire tea. If anybody wants some Yorkshire tea. So my role here is generally working with the faculty on getting types of high technologies like virtual reality, augmented reality, high performance computing into their research. I work across the board. So I'm one of them people who is knowledgeable in a lot of subjects, enough to be dangerous sometimes, but also my background is generally in heritage and archaeology, in the visualization aspect of it. But I'm also a software developer, and I own a software development company back in the UK, generally focusing on virtual reality experiences and augmented reality experiences. So to be honest with you, yesterday I had a bit of a crisis of confidence. I had definitely an imposter syndrome moment, and I was sat over there and I was thinking, oh my God, what am I doing here? Like, all these folks have got all these amazing technologies. We've got hugging robots, we've got baby robots that people play with and stuff. And I really felt out of my element a little bit. And then I think it was James said something yesterday. He said that developers aren't carers. Like, developers don't work in care. And we're not always that path. I want to flip that on its head a little bit and say, researchers don't always work on code and development that actually goes to market or goes to like full development that's actually open to people and normal people. It's generally kept within the research labs. So what I'm going to talk about today is a bit of my mindset of what we go through when we're trying to develop applications for virtual reality, for augmented reality, for mixed reality, and what we implement as part of accessibility and what type of tool sets we use for making accessibility, making the actual virtual reality experiences more accessible to everybody. So I'm going to talk a little bit through about different stuff. So generally standards, why standards matter for developers like me. Then I'll work through a bit of a tool set of all the different tool sets that are currently available to people. And then I'll talk a little bit about bridging gaps between sensory experiences, but also bridging gaps between developers and researchers and how that works. So as you all do, we all communicate with ChatGPT. So I asked ChatGPT to look at my presentation and give me some sort of like question what I think of things. And this is what it said. It said, what if digital world was accessible to all? It also said to me, when you're talking to people, give a personal anecdote of something that connects you to the audience. So that's what I'm going to do. So when I first arrived in America, it was the precipice of the current generation of virtual reality. So it was like the start of the Vive and that type of thing. I was actually working in Minnesota at the time, and we went to it was like an arcade but for virtual reality. And we done our session, we were playing about, and then from one side of the room, you hear lots of shouting and screaming, and basically what was happening was actually the police were doing an active shooter experiment in virtual reality. And the other side of the room was basically a family with an elderly person who was super giddy, screaming and shouting, laughing and joking. So after our session, we went over to obviously speak to the elderly person and their family, and we were saying, so what were you doing? And she was a 90-year-old, and she was sat there doing virtual reality. She was actually getting people to take her to places where she grew up. So they basically would walk around the location where she grew up and would access that type of environment. She could put the headset on, she could do Google Maps, but in 3D, and go back to the place where she grew up, which I thought was just amazing. Like, it was like so much like, if my grandparents were still alive, they would have loved to basically explore the world and see that type of thing as well. And also a personal anecdote as well. What makes me so interested in accessibility, I am losing vision in one of my eyes. So I have a personal stake in making sure I can actually still play video games and still do virtual reality as I get older myself. So it's vitally important. And I heard some folks talking about UNESCO yesterday and things about standards and policies. Standards matter, especially for developers. It's when we don't have access to researchers, it's what we go back to look at what is available, what we can and can't do, what we should be doing and what we shouldn't be doing. It's hard when if you don't have someone with disabilities or access to people with disabilities to figure out how to implement that type of thing in the system. So having standards allows us to be consistent across the globe. It also gives us guidance as a developer. And also there's a legal and ethical standpoint that we should be making things more accessible. Like my first slide said, it would be amazing to have a world where people could use virtual reality. Also, sorry, something I didn't mention before, I asked ChatGPT to make a picture of the question as well. So that's what this is. Basically, you got people using their phones on one side and then people using virtual reality and stuff on the other, which I thought was quite cool, so I thought I'd use it. So there's a lot of standards available right now. Most of them aren't law or written into law, apart from the general accessibility acts like the European Union Accessibility Act or the US Rehabilitation Act. Most of them are just standards and guidelines. So the IEEE has a bunch of guidelines specifically on virtual reality and augmented reality and the ethics and development of that type of tool set. They also have the W3C schools as well, which you've probably all seen if you come in contact with web development at any point. So they have also web accessible stuff. One of the most interesting things I came across only a couple of days ago, actually, is the Access to Prescribed Digital Therapeutics Act in the US. And it's currently going through the Senate and the House of Representatives right now as well. I'll talk a little bit more about that in a minute when I go back to my original story. So as a developer, I'm obviously at the precipice on the forefront of VR development and this type of access. It's my role at Pomona as well to also look into this stuff and make it more available to our students, but also to the faculty here and have it in their research. So I always have to keep up with the process and how everything works. So I always feel like I'm the pioneer in making inclusive access to things and inclusive technologies. And I actually wanted to start addressing it from the get-go. So we develop it at the start. So I work with a bunch of students. They develop applications for me. I teach them about this straight away. I teach them about the accessibility stuff, how to push it into the development that we're doing from the start. So it's not an afterthought. It's not something when we go to a research lab and someone's like, oh, well, I can't use this. We try and think of it ahead of time and make sure it's in. I also introduce them to the standards and guidelines as well to make sure that they're aware of what we're legally responsible for, but also ethically responsible for as well. Making sure that we can make these things more accessible. And also we've got a large community of students. We've got 7 colleges in this area. So making it available, collaborating with other students, collaborating with the other student groups available, collaborating with other faculty in the area to make sure that we can actually test out these types of tools and tool sets and virtual reality and all other types of tools. And also just learning continuously. My role here is unique in the sense that I get to do that. I get to be a researcher in ITS, but also work with everybody across the whole of the campus. So there's a lot to consider when it comes to accessibility in virtual reality. And obviously there's the usuals of the physical, sensory, and cognitive accessibility, but also the technical economic barriers as well. Obviously, the VR headset can range anywhere from a couple $100 all the way up to the Apple Vision Pro right now, which is $3,500, and you have the HoloLens, which is also a similar price as well. So it can be expensive, especially when you talk about elderly care and care facilities and things like that. They can't afford to buy these types of technologies a lot of. We can't afford to buy them for our own classrooms, so it's expensive. And also looking at custom content as well, allowing people to develop things in the application itself that represents them. It's a lot of what we talk about right now as well. Like, I think that stuff like AI and things will help with that process a little bit more, but I feel it's a really difficult technical barrier to develop right now. You can't develop everything for everyone, so it becomes really difficult. So my tool set of what I follow is generally inclusive design principles. So start from the ground, like I said, develop them, leverage the accessibility guidelines. But one of the big things that I want to talk about a little bit as well, once I go on a bit more, is utilizing accessibility tool sets and accessible plugins, and like using some open source, access to open source systems. So when you all talk about research, a lot of that research is closed and closed access. It's not available to developers. It's not available to other researchers. There is ways to make that available and make these tool sets available, especially with plugins and things like that, and developing the plugins for us to utilize accessible tool sets. So I'll explain what I mean. But also, yeah, like, so a lot of the stuff I use is built in Unity. So Unity is like one of the standard development gaming environments. I think most people here use it. I put this slide on just because in case people didn't know what Unity was. It's a video game engine. In all intents and purposes, it's designed for making video games. You've probably all seen this sign made with Unity. You probably all, if you're a gamer or anything, you've probably all groaned with this sign as well. It's because it's so easy and so accessible, you get a lot of people using that tool set. And it means that you get a lot of things pushed out with Unity. And you've probably seen Pokemon Go and Fall Guys as well. So in education and in research, Unity is used a lot for prototype simulation and for building prototypes out, for simulating things. We also use it a lot for developing, like, yeah, educational tool sets. So in my bio, I said about doing development of schizophrenia simulator. So that was an empathy study we were looking at in my previous institution at Carleton College. So we developed an environment in Unity. We developed a classroom, the actual classroom where the students were. We did motion capture on the faculty's face, capture on the faculty's face, done motion capture on him moving. He gave a lecture, a full lecture in the classroom. And then one of the students was sat at the back of the room. They would have the headset on. And it would simulate what it would be like to have a schizophrenic episode in the classroom, in the actual classroom where they were as well. So adding that element. And we've actually just published a paper that's getting released next month, I think, on that type of research. So I know it was all built in Unity. And Unity is nice because it has such a low barrier as well. Like, you don't need as much coding experience to develop in Unity, which is really nice. And also it's got a massive community right now, so you can build stuff in it. So when we talk about frameworks and making things open access, as part of the Unity development system, you can actually pull in other tools as part of Unity. They can be open source, they can be plugins, they can be assets, what Unity calls them. And they all add functionality to Unity. And we have lots of different examples here. Right now, there's only a total of 18 accessibility tool sets. There's over 1 million assets on the Unity framework right now, but only 18 that are developed to do with accessibility, which to me is crazy when you think about how important accessibility is. So one of the free ones available is something called the Unity Accessibility Plugin, and it's basically a screen reader for Unity. You can drag and drop the code into your code base, and then it will make all your applications available to screen readers, and it will talk and show you how to implement a screen reader for a blind person in your application itself. It is drag and drop. There is no additional code base. You don't have to code anything. It's also free. So as far as the barriers go, this is very simple. There's no reason why we're not doing this type of stuff. And there's also something called Chirp as well, which is caption system. So it will capture what you're saying, and it will also display what the avatars are saying as well. It does unfortunately use with AI, which is owned by Meta, sadly. And I'll go into Meta in a minute. But yeah, so it's actually owned by a commercial company. But Chirp itself is open source, and you can implement it with other types of models. And then also just the basics of locomotive, especially in VR. Obviously, I've got eye damage, so I get motion sick very easily nowadays, sadly, in virtual reality. But understanding how people move in virtual reality is also, yeah, vitally important, especially when you're talking about disability and disability access. You want to be able people to be able to move in accordance to how they feel they should do in virtual reality. So then you get to bridge the sensory gaps. There's a bunch of strategies we can do. Obviously, adaptive text and adaptive sizes. You've got contrast and color adjustments, enhanced audio, and yeah, cross-model sensory stuff. So large language models have changed the game a little bit when it comes to this type of stuff. We can now push in a large language model and have a conversation with a computer. We can have it understand our voice and access. So things like voice commands are very simple things to do nowadays. But also stuff like customized UI as well, looking at how the UI scales to people's eyesight is insanely important when they can't see. And especially when you've got like a massive goggles on your eyes as well, it's not the easiest thing in the world to deal with. So I just want to jump a quick little bit. So I want to talk about a few case studies of, so we're going to talk about two grassroots communities using accessibility tools in virtual reality, and then one is semi-virtual reality of how they're done. So one thing I found in my adventures across the internet was something called Helping Hands. So it's actually a virtual reality community in VR chat, and they've developed a whole new way of communicating in virtual reality using virtual reality sign language. They actually host classes in VR chat, and will teach people how to use virtual reality sign language. So you can actually use your controllers to manipulate the avatar's fingers and hands to communicate with someone who's deaf in virtual reality. They also do a bunch of classes. You can sign up for classes, you can sign up for events and movie nights, and it's really, really interesting. So I have a couple of examples. I don't know if it actually plays, maybe. Oh, no, sadly. So they do, that was a video. I don't know, it's not playing. But it's basically, it shows you the ABCs of American Sign Language, and my British folks, they also do British Sign Language as well. They also do Korean Sign Language. They do a lot of different variations of sign language. It's a unique set of sign language. It's not standard. It's VR sign language, so it's a whole new language and way of interacting. So I wanted to jump back to my original story of being in that virtual reality environment, the virtual arcade originally. So when I was talking to the elderly individual's family, I was asking them, has she used VR before? And they were like, oh yeah, she's used VR a ton. She loves VR. I was asking her why and when she used VR, and she was saying, well, one of the care assistants, the elderly care facility she lived at, would bring virtual reality headsets to the patients there. He would put the headsets on them. He would put them on the beach. They would get a hot fan in front of them, and they put a hot fan on them, and they'd sit on the beach in virtual reality, having a beach day. And I was like, I think it was Callum who said about yesterday about karaoke, like the simplest thing. It's like you can't get more simple than a 360 video of the beach and these elderly people in care facilities basically enjoying themselves on the beach. So I think there's a lot of research that's adapted to that. There's digital therapeutics is a emerging market, a massive emerging market, and it also goes into stuff like PTSD as well. I know soldiers use a lot, if they've got burn victims for soldiers, they will put them in a cold environment in virtual reality as they're changing their bandages on their skin and things. So there's a lot of research adapted to this type of research, this type of work as well. But then some of the things, I was talking about commercial stuff. Obviously, you've got stuff like Horizon as well, which is virtual reality. It unfortunately is owned by Meta, but also able someone to put on a VR headset and interact in an office environment, regardless of what their physical accessibility is. They can put on the headset, they can work in the environment, they can work in an office environment, they can have a regular meeting. So tools like this are really important, but unfortunately, right now they're owned by commercial companies. I wanted to put this on because obviously the conference is more about elderly care and or care in general. So NVIDIA is sort of side connected to VR. I know it's very cheap, but it's a big company. So they obviously have been pushing a lot on AI, and they have this AI framework right now of, yeah, like using a chatbot to be your nurse or your doctor and discussing with it. So I just skip a little bit because I'm going over time. So I want to go back to this slide a minute and talk about like bridging the research gap a little bit and how we connect as developers and connect as researchers together and try and stop corporate dominance a little bit of this type of work. A lot of folks who work in research will go on to big companies and work. When you talk about research and coders, they are generally places like NVIDIA, places like Meta. They're not the smaller companies where they have research or researchers working with them to develop code. So I want to try and get away from that corporate dominance. Like imagine a world where it's about because everything being accessible. Imagine a world where it's basically Meta or nothing. You have to be in the Meta environment to work in your office. That's the type of thing I don't want as well. Also, open source initiatives are massively important. Like I said about the plugins, making your research available and making the code available so we can push this into Unity environments. I'm not talking about commercial stuff. Like obviously there's a weird thing about commercial stuff, but making things more available for people and to experiment with, play with, to push out to care facilities or for accessibility reasons, like making the tool sets just available would be amazing. And then the future, I've talked a little about Unity. Obviously VR, obviously large language models is going to be exploded for everyone. It's the same with development environments as well. Unity has pushed in large language models like crazy. So, and then I skipped over that very quickly because I knew I was a few minutes over. Thank you. And then are there any questions or? I know it was a slightly different talk than most of the others, but yeah.
Thank you for that. Sorry, apologies for my voice, by the way. Thank you for the very interesting presentation. I did initially have a couple of questions regarding accessibility, kind of in terms of hardware and the way that VR is designed, but you actually did address them quite well. So now I have more of a comment, I suppose, with a simple question attached. So both in my master's research and in my PhD, I worked with people with significant physical impairments in the ways that they kind of considered or the kinds of accessible technologies that they desired. And in both cases, one of the major things was VR, both in terms of in kind of pure entertainment, right? Particularly for younger people who are, kind of big gamers and who suffered kind of traumatic brain injuries or something, for example, and were unable to use their hands, as well as in the kind of elderly example you provided in terms of digital therapeutics, which is a term I haven't actually heard before. But at a number of my field sites, both kind of elderly residents and their rehabilitation experts really wanted to find a way to allow these people to kind of travel in ways that they are kind of physically incapable of doing as they get older. For example, there was one rehabilitation expert who took the elderly around basically doing laps of the facility as a way to kind of keep them active and to stimulate kind of a digestion and those kinds of things. And he found it really difficult trying to get these people excited to walk around the same floor over and over again. And he said that if he could have a way of putting them in a kind of virtual environment, like a VR situation, it would kind of inspire them and give them something entertaining to do. So I guess it, more of a comment than a question, but I do find it nice to know that these kinds of technologies are being developed and that people are taking these kinds of things seriously. But I guess to make it a question, are you aware of how much of a push there is for this kind of development? Is it something that's kind of building, or is it still a relatively small thing?
It's still a relatively small thing, I think. Obviously, people do it. Like obviously that was a anecdotal evidence, but and I couldn't. I looked and scoured the internet, but I couldn't find any actual like pictures or anything of that actually happening. But I've heard it happen, and yeah, like you do hear of folks like wanting to. In my own personal experience, I have a exercise bike that attaches to my VR headset. I can ride around Wales, where I used to live, in VR on my exercise bike. So there's technology available already. I think getting it into the hands of people who can use it is always the hard thing. And so my software development company back in the UK, we worked for with the NHS a lot on early onset dementia and things, but we never worked in virtual reality, which we're trying to push and move into that type of field. I think the problem with this type of technology, it takes a while for it to. Gaming is the first field to start, and I think that's where it's gonna start from. It's like the Wii. Like the Wii, we were to pick them. Like you've seen people in care facilities playing bowling on the Wii. I think it's just the next development of that type of thing. But the price needs to come down a bit more, I think, before it can actually be more viable. And software developers are developing things for people and accessible, and grassroots folks as well are developing a lot of tools and using what they have to develop things to make it more accessible as well. Because VR headsets itself are not accessible. Like,
Thank you. It's more like a comment. We have in our facility at home, we have a VR headset that's made by a Danish company called ThinkSense. And it's for elderly people to get rehabilitation and with VR and a bicycle. And the VR set was sent to the moon with the last, I think, the Danish astronaut Andreas Mogensen. He had it with him, and he came down, a few days ago. Yeah.
Hi. Out of curiosity for myself and others, what would be the process of if someone was interested in joining you in like research, this type of research, and what kind of prior background would you expect for them to have before they were to?
So if you're a Pomona student or a 5C student, just send me an email. I have a lab in So in ITS, I have over here, I have a lab where I have virtual reality and augmented reality and all that sort of cool stuff. I have students working there generally. They will generally build applications and build software for the faculty. So just get in touch. As far as background goes, my background is really eclectic. My PhD is in archaeology, but I end up in this type of field because obviously visualization of heritage data is dragged me along into other fields and other research fields, especially with augmented reality. I have a research project right now looking at how to visualize proteins in the classroom using AR for undergrad students. So there's a lot of everything interconnects basically. So there's always ways of learning this type of technology. So.
So thank you for your talk. It's a very interesting topic, and to me, so I'm a computer science student, and like before, I worked a lot on like software, and also like I worked on projects. Like I built the first Vietnamese sign language like online learning platform for the deaf community in my home country in Vietnam, and I feel like as a developer, it's very like we all know that the important thing is to like we have to go from the target audience, like what do they need, and like seek feedback from them before we even develop the technology. So I was just wondering, like for you, when you work on these real projects, like how is that process for you? Like how do you work with them? Like just like how is the workflow? Yeah, thank you.
So it depends on the project, really. Obviously, if it's more, so like the schizophrenia simulator, for example, is we obviously worked with a psychologist at that point. We worked with someone who understood what it was like to have schizophrenia as well. And we then tried to develop that in the environment. So we worked with them closely and we said, is this what it's like what about this? We had like visual hallucinations, and they would tell us what the visual hallucinations were like. People always assume that, yeah, they're like real people and they see real people, or they see like fully formed things, but it wasn't. It was like shadows. So they like shadow people. So they would have like shadows at the corner of their eyes, and they would get closer and things. And they would have like people telling them really horrible things sometimes as well. So like at the back of the classroom, it might be like where another person is sitting, it might be something really horrible. So working with people working with your target audience a little bit as well, yeah. Like, and if you're developing something for a more open market, then it becomes more difficult. But having accessibility tools in is not that difficult. Like the Unity UI tool set is a plugin. You drag and drop it into the Unity code base. You press go. Like that's not a difficult thing to implement into an application. Really, it doesn't add an hour of time to the development process. So then you're making it more. You're growing your target audience. At that point, you're making your target audience much larger in that sense, just by making it easier for people to do what they want to do. And I think gaming is like should be more accessible. Like obviously, going back to personal anecdote. So one of my personal reasons is, so my brother was severely disabled originally, and sadly he passed away. But my connection with him, I always felt would have been video games. So making video games available to him so he could play them, because that's what I love. So it's important for making it available. Sorry, I'm very like preachy. I feel very preachy right now, but I feel like it's an easy ask as a developer. It's not that difficult to implement these open, especially when they're open access and open source. Like I really love all the research we do, and it's always super exciting doing research. But making it available is also important. I think like the NSF, the AHRC, all these bodies now want you to make your work more open access and more available to people, so we can carry on and make life easier for everybody. So, but to answer your question, I was a bit preachy.
Yeah, thank you so much. Yeah, I just recently also just started doing some robotics research, like simulation with like Unreal Engine. So yeah, it's just very interesting to hear.
Yeah, I do love Unreal, but it's very big in comparison. It's very designed for video games right now. So yeah.
Thank you very much. Let's thank all the presenters. And we're on time. And so I think we have 15-minute break. Huh? Snacks outside. Snack time. And then nap time. No. So see you in 15 minutes back here.